Okay, in this section we're going to learn how to solve multivariable linear systems. So you already have good practice solving systems that are linear of two equations. This is going to focus on three equations. But before we get to three equations, let's look at a system of equations that has infinite solutions. All right. Now, how do you know a system has infinite solutions? Well, if the two equations are the same line graphically, that means that the two lines would overlap when you graph them, and we'll look at that on the calculator. But how would you know this algebraically? Well, when you go to solve it, so by elimination, so let's say we take this top equation and multiply everything by -2 to eliminate our x variables. So we get negative 10x plus 4y equals negative 26. And then take this bottom equation and just rewrite it. Sorry, having some difficulties with the stylus. Oh, come on. Alright, so we go to eliminate the x's, and the y's also eliminate. So that tells us that there's either infinite or no solutions. Now, since we get a negative 26 plus a positive 26 is 0, we get a true statement, 0 equals 0. That means there are an infinite amount of x and y coordinates that work in this equation here, in these two equations. Now, that doesn't mean every solution works. Like, that doesn't mean you could just plug in random values for x and y and it's going to work, but there are an infinite amount that do work. All right, and the way to express those points is to isolate one variable. So let's say we'll get everything in terms of x, all right, and now I'm going to solve for y. So if I were to take that top equation and then subtract 5x on both sides, I have negative 2y equals 13 minus 5x. Divide by -2. Alright, so I get y is equal to 13 minus 5x over -2, which means that my solution could be represented as x, comma 13 minus 5x over -2, where x is any real number. Now, from there, you could get, you could figure out some specific solutions. Like, for example, if we let x equal 0, now we could plug 0 in for x into the other part of the equation. Alright, so we get like 5 times 0. Come on, sorry. It's hard to do on the iPad. Alright, so if we plug in 0 here, we get 13 over -2, which is negative 6.5. So like that would be one of many of infinite solutions. Alright, let's say we plugged in, let's say we plugged in 1, for example. Alright, so we get the point 1 comma 13 minus 5 times 1 would be 8 over -2, so you get -4. So that would be another set of solutions. Alright, and then if we just kind of check this with a calculator, so I graph these two equations here, 10x minus 4y equals 26 and 5x minus 2y equals 13. Alright, we can see that these are both the same lines. And when I go to see where the graphs intersect, since they're the same line, every point on one line is on the other line. So you see there's the point 1 comma -4, which was one of our many solutions. There's also the point 0 comma negative 6.5. And all of these points here are in that form x comma 13 minus 5x over -2. Alright, so that's how you represent a set of infinite solutions.